All right, settle in, because the global discussion around artificial intelligence,
Mhm.
it just got violently upgraded from theoretical to terrifyingly present.
Mhm.
The tech world has been hit with what might be the boldest claim ever made. I mean, ever in the history of computing.
It's a big one.
We are talking about a Tokyo-based company, Integral AI, making a truly seismic announcement. They claim to have officially built the world's first AGI-capable model.
It really does feel like one of those moments in history,
Yeah.
like breaking the sound barrier. But this time, the barrier is intelligence itself.
Exactly.
And what's so fascinating to me is where it's coming from. This isn't from the usual suspects in Silicon Valley.
No Google, no OpenAI.
None of them.
Yeah.
It's coming from this company, Integral AI, founded by Jad Tarifi. And he's got the pedigree. He's an ex-Google AI veteran.
Mhm.
Spent nearly a decade there building some of their earliest generative AI systems.
But he left. He deliberately left the valley.
He did. And his choice of location wasn't just, for a change of scenery.
Right. He didn't just throw a dart at a map.
Not at all. He set up shop in Japan, quite deliberately. The sources say he specifically cited Japan's, its established global dominance in advanced robotics.
So from day one, this wasn't just about a chatbot.
Exactly. This suggests that from the very beginning, this AGI wasn't meant to live purely as a digital brain on a server farm. It was always meant to be embodied.
To be active in the physical world.
Yes, interacting with real physics, real machines, and, real consequences. That alone tells you a tremendous amount about the scope of what they're trying to do.
Okay, let's unpack this language immediately because we have to clear up the AGI-capable phrasing.
The phrasing trap.
Yeah. Integral AI is claiming the latter, but if they are capable, doesn't that just mean the goal has been achieved? It feels like they're trying to soften the blow a bit.
I think you've hit on it perfectly. Historically, AGI has been this sort of mythical, highly generalized goal. A system that can learn anything a human can, reason across different domains.
And eventually outperform us at everything.
Right. So if Integral AI comes out and says their model is capable of all that, they are, in effect, staking their claim on having achieved general intelligence.
So the capability isn't a hypothetical, it's a verified measure. It's like you don't say a person is capable of having a 150 IQ unless they actually demonstrate it on a test.
Precisely. If the system can pass the developmental milestones they've set out, then the capability is the proof. And by doing this, by staking this claim, they're forcing the conversation out of the realm of, sci-fi speculation.
And into the realm of technical verification.
Yes. And that's what makes this whole announcement so fundamentally different from every other world-first claim we've heard over the last decade.
Right. I mean, if you recall the disputes that followed Google's quantum supremacy claim years ago,
Oh, yeah.
or the early arguments about whether language models were really learning, it all just boiled down to definitions.
It always does.
Integral AI seems acutely aware of this. They know people are skeptical, and that's why the definition they provided is the absolute core of this deep dive. They didn't just say, hey, it's smart like a human.
No, that would have been dismissed immediately.
They laid out 3 specific, measurable criteria for AGI's arrival, which is where we need to head now.
It was a strategic masterstroke, really, to provide those hard developmental cornerstones. It lets them sidestep the whole philosophical debate about consciousness or, sentience.
For now.
Anyway, for now. So our mission today is to go beyond the hype and really understand their specific technical and ethical blueprints. And maybe more importantly, to see how the global power players, from DeepMind all the way to the Vatican, are positioning themselves now that the goalpost might have just been, fundamentally crossed.
That's the agenda. Let's dive straight into the heart of the claim. Integral AI's 3 measurable pillars that define this new AGI.
What stands out immediately is this complete departure from, the traditional machine learning benchmarks we're all used to.
Like what?
Well, for decades, the pursuit of AGI was sort of bogged down by these vague targets like pass the Turing test or win every game.
Right, things that sound impressive but don't really capture general intelligence.
Exactly. Integral AI avoids all that vagueness. They've established these cornerstones that are technically verifiable and, frankly, incredibly radical in their implications for how we train systems today.
Okay, so if they're avoiding the philosophical stuff, they must be focused purely on function and efficiency. Let's start with Pillar 1, autonomous skill learning. Tell us what this massive claim of self-sufficiency actually entails.
Pillar 1 is defined simply. The system must be able to teach itself entirely new skills in entirely new domains.
Okay, that sounds like a standard machine learning goal on the surface.
It does, but the critical part is what they exclude. The learning process must require no pre-existing data sets, no human supervision, no labels, and no fine-tuning.
Wait, hold on. No pre-existing data sets and no labels. How does it even know what success looks like? That is the absolute foundation of modern AI training.
It is.
Whether we're talking about massive supervised learning sets or even reinforcement learning where a human has to design the reward function, you're saying they've thrown all that out.
That's the claim. It implies a fundamental shift in the mechanism itself. I mean, think about the most advanced models we have now.
Right.
When you want them to perform a new specific task, say managing a complex logistics chain, they need massive curated data sets, all about logistics. And then intensive human-guided fine-tuning to perform well.
They're completely dependent on pre-processed human knowledge.
Completely. Integral AI claims their system, when presented with a new domain like operating a complex, unfamiliar robotic arm in a factory or running a brand new piece of simulation software, it could just observe the environment, set its own internal goals, and figure out the operational logic from scratch.
So it's less like training a dog to fetch a specific ball and more like dropping a child in a new country and just watching them organically deduce the language and the customs through pure interaction.
That's a great analogy. It completely changes the definition of training if you eliminate the human in the loop, the person providing labels and supervision.
You eliminate the massive multi-billion-dollar bottleneck that has defined the last decade of AI development.
That is the core implication.
Yeah.
It's a shift from dependency on structured data to, well, self-sufficiency based on conceptual abstraction. Now, achieving that leads us directly to the necessary next stage, Pillar 2.
Which is safe and reliable mastery. Okay, so why is mastery a separate pillar from learning? Isn't the proof of learning the fact that you've achieved mastery?
Not necessarily, no. Especially not in machine learning. Sometimes the system learns something, but that learning it's unstable or it's unreliable or it leads to really weird unintended side effects.
Hallucinations, for instance.
Hallucinations are a perfect example. So Pillar 2 insists that the entire learning process from start to finish must happen without catastrophic failures or unintended harmful consequences.
And this becomes absolutely critical when you link it back to Tarifi's decision to base the company in Japan and focus on embodied intelligence.
Yes.
We are not just talking about a language model getting a fact wrong. We're talking about systems that interact with the real physical world through robotics.
Absolutely. Think about it. If an AGI is autonomously teaching itself how to operate, say, a crane in a warehouse, the occasional catastrophic failure doesn't just mean a glitch in the code.
It means 100-ton load drops unexpectedly.
Right. A system that learns on its own but, occasionally decides to drive a robot arm through a wall isn't helpful. It's a massive liability. So by insisting that mastery must be reliable from the very start, they're essentially claiming that their architecture inherently prevents the chaotic, unpredictable outputs that plague these less stable, purely predictive models that don't genuinely understand causality.
So Pillar 2 is a necessary safeguard. It demands stability and real-world compliance be woven right into the system's DNA. Okay, now, this third pillar. This is, in my view, the true headliner. Because it sets a physical constraint, not just a computational performance metric. It's pitting the system against the biological world.
Pillar 3 is energy efficiency, the biological benchmark. And the requirement here is it's genuinely stunning. The total energy cost for the system to learn a task must be roughly equal to or lower than the energy a human brain uses to learn that same skill.
Wow. Okay, stop there for a second. We are talking about reducing computational overhead to the level of human metabolism.
Let's put that into context because this truly is the seismic change for the industry.
Right.
For modern frontier models to achieve even their current level of functionality, the training requires thousands of specialized GPUs.
Thousands.
Running for months, burning through megawatts of power. The training energy consumption of a single massive LLM, it often equals the annual power usage of a small city or a small country.
The energy bill alone must be staggering, not to mention the environmental costs.
It's a huge problem. And what does the human brain use?
I'm almost afraid to ask.
The adult human brain operates on about 20 watts of power.
20 watts.
Less than a standard light bulb. Over the course of a day, fueled by, a couple thousand calories, we can learn, process, and generalize incredibly complex information. To claim they can achieve human-level learning efficiency is to claim they have solved a fundamental bottleneck in computational physics and model architecture at the same time.
So this wasn't an accident.
No. Tarifi says his engineers treated these three principles as non-negotiable developmental cornerstones, meaning they designed the system to be efficient from the ground up, not just trying to optimize an existing inefficient architecture.
If that's true,
Right.
then they didn't just stumble upon a big model that happens to perform well. They designed the core architecture specifically to be minimal, energy efficient, and biologically grounded.
Mm-hmm.
The implication there is profound. AGI development stops being purely a capital-intensive problem, something only solvable by nations or trillion-dollar corporations, and it starts becoming an architectural problem.
And if learning costs drop this low, access to AGI capability becomes, well, drastically democratized.
Which is both exciting and terrifying.
Very. And the source material claims they have a proof of concept. The evidence they've cited includes successful tests in real-world robotics trials, where robots autonomously learn new skills in the physical world.
With zero human supervision.
Zero. That real-world application is the proof of the pillars. Autonomous learning, reliable mastery, and achieving it all at a fraction of the traditional computational cost. The capability is showing up in the results.
Which brings us directly to the question of how. I mean, if they've cracked the energy code and the autonomous learning code, they must be doing something fundamentally different than the massive transformer models, the LLMs that we interact with every day.
They have to be.
And Joe Tarifi claims the entire architecture mirrors the human neocortex.
The neocortex, for anyone needing a quick refresher, is the largest and most recently evolved part of our brain. It's responsible for all the higher-order functions: conscious thought, spatial reasoning, sensory perception, language.
Basically everything that makes us intelligent and adaptable.
Right. When we talk about what makes us human, in a cognitive sense, we are talking about the neocortex. So by claiming their architecture mirrors this, integral AI is signaling a complete departure from the current mainstream.
And that departure centers on a conceptual gap. Current advanced LLMs, even the superstars like GPT-5 or Gemini-3, are still described, according to Tarifi, as just sophisticated pattern matchers.
And that's a crucial distinction. These models are brilliant. They're brilliant at predicting the next token or generating coherent, beautiful text or filling in the pixels of an image. But they do this through massive statistical correlation.
They're just recalling and arranging patterns they've seen billions of times.
Exactly.
But
according to integral AI's analysis, they still fundamentally lack structured abstractions. They don't have a genuine internal model of reality, of causality, of how things actually work.
so the consequence of being a sophisticated pattern matcher is that the systems are inherently, what was the word he used? Inefficient and brittle.
Inefficient and brittle. They are incredible at recalling or rearranging what they've seen. They're a fantastic memory palace, but they struggle with genuine novelty.
Because they lack the conceptual understanding of why things happen.
That's it. If you change the rules of the game slightly, their performance just degrades dramatically because they only know the patterns of the old rules. They don't understand the principles behind them.
So what's the integral AI difference? How does this architecture actually function as a mirror to the neocortex?
Well, Trebi states that their system doesn't operate as a single, static predictive model. It's a unified process that grows, abstracts, plans, and acts all at once.
So it's not just sitting there waiting for a prompt.
No, it's not simply reactive. It is continuously modeling the world and preparing to execute actions based on that model. This is the core concept they call abstraction-first learning.
Abstraction-first learning. That sounds like the inverse of the prevailing data compression model we're used to.
It is the conceptual opposite. Current LLMs, you could say they compress massive amounts of raw data. That makes them essentially high-fidelity prediction systems. Abstraction-first learning, on the other hand, compresses knowledge into deep conceptual structures.
Can you give us an analogy to make that clear for the listener? What's the real difference between compressing data and compressing knowledge?
Okay, think about a massive library, millions of books. A typical LLM is like a librarian who has memorized the exact location, the content, and the index of every single book in that entire library.
Okay.
If you ask it a question, it can tell you exactly where the answer is, or it can quote you similar passages from 1,000 different books that has
Right.
perfect recall of the data.
Right.
The abstraction-first model, however, is like the architect who drew the blueprints of the library. It understands the structural relationships between the sections. It knows the hierarchy of the classification system. It understands the physical laws that hold the building up. It can rederive the location of a book based on its knowledge of the system's principles, rather than just reciting a memorized fact.
That's a wonderful distinction. So it can apply these conceptual models to entirely new, unfamiliar problems because it understands the principles, the blueprints, not just the memorized instances.
And the result of this abstraction is a system designed for continuous learning and adaptation. The architecture doesn't just reason. It's built to survive and thrive in new environments. It plans actions. It executes them. It generates its own training data from the feedback of those actions. And critically, it performs what Rafika calls dreaming.
Dreaming. I mean, that word choice is so loaded.
It is.
It suggests it's a computational equivalent of the neurological process that happens during sleep, which we know is crucial for consolidating learning and moving information from short-term to long-term memory.
And it speaks to the efficiency aspect, too. If the system can internally simulate and consolidate what it's learned without needing constant external data interaction, it cuts down on resource usage exponentially. And this internal process, this dreaming, leads directly to their solution for the most frustrating, long-standing nightmare problem in machine learning.
Catastrophic forgetting.
Catastrophic forgetting.
This is the machine learning equivalent of like upgrading your phone and losing all your old photos, or worse, losing a core piece of your ability to function.
Exactly. And it's a massive instability issue for any system that's intended to operate in the real world for a long time. For decades, if you trained a classical neural network to, say, identify cats,
Right.
and then you immediately trained it on a completely new task like identifying dogs, it would often just lose its previous ability to recognize cats entirely.
The new learning overwrites the old learning.
It overwrites the weights. It's unstable because it cannot naturally integrate new knowledge. It has to forget something to learn something new.
So how does integral AI claim to have circumvented this fundamental architectural flaw?
They argue that because their system is abstraction first, because it's continually updating its world model, and because it uses this dreaming consolidation process, it completely avoids catastrophic forgetting.
So new knowledge isn't seen as foreign data.
No. It's seamlessly integrated into the existing conceptual structure, the blueprint, without damaging previous capabilities. If this claim is true, it's not just an improvement on current AI. It is the fundamental architectural change required for any truly stable general intelligence that's intended to operate lifelong. The system is designed to grow, not to be replaced.
Okay, so moving from that technical blueprint, the architecture that enables this autonomous learning integral AI has also laid out a clear conceptual path for how they intend to scale this AGI-capable model toward true superintelligence.
Yes, Terrify breaks this down into three conceptual phases that, they flow very naturally from one to the next. It's about understanding the world, then acting within the world, and finally, the infrastructure that supports both.
So if the abstraction-first architecture is the brain, then phase one is about building the mind itself, the universal simulators. This is the structure that gives the AI genuine conceptual understanding.
And this is what addresses the brittleness of current LLMs we were talking about.
Exactly.
The function of the universal simulators is to build a genuine, unified, and holistic model of the world. This is the world model that the entire industry is now obsessing over.
Right. Everyone's talking about world models now.
And we said LLMs are pattern matchers, operating on a flat, vast stream of text data. Simulators overcome this by employing something called hierarchical processing.
What does hierarchical processing look like in this context? How does that work?
Instead of treating all data as equal, the simulator processes information in layers, building increasingly abstract representations of reality. Think of it like a pyramid.
Okay.
The bottom layer handles the really granular sensory input, the raw pixels from a camera, the individual sound waves from a microphone.
The raw data.
The raw data. The middle layer organizes those inputs into objects and actions. It identifies a cup, it sees the act of pouring. Then, the top layer builds concepts and causality. It understands that pouring water from a cup achieves the goal of hydration, or that if I let go of this cup, gravity dictates it will fall.
So it's moving from perception to conception.
That's a perfect way to put it. This layered approach is what enables genuine reasoning and deep prediction. It moves beyond just predicting the next word to predicting the next event in the physical world.
And the physical world is inherently multimodal. The AI has to process vision, language, physical forces, all at the same time.
That's the core mandate of the simulator. It combines all of these data types, vision, language, audio, and crucially, physical sensor data from robots, into this one unified world model.
So it's not just gluing different models together.
No, it's not a Frankenstein's monster of models. It's creating a single integrated conceptual map where physical rules, linguistic rules, and social rules all coexist and interact.
Yeah.
And critically, these simulators employ lifelong and dynamic learning through something they call gradual expansion.
Gradual expansion. So that means the AI itself isn't a fixed product that needs a massive, painful rebuild every year.
Exactly.
It's more like a muscle that grows as it's used.
Precisely. Its size, its context window, its knowledge depth, it all grows dynamically as needed. It's an ever-evolving system, not a fixed, frozen model that requires a full, multi-million-dollar retraining every time it encounters a new variable.
That's what makes it general.
That's what makes it general. It can continually incorporate novelty without breaking its core understanding.
Okay, so once the universal simulators have built that deep conceptual model of reality, the blueprint, that knowledge is pretty useless unless it can translate that understanding into effective action.
Right.
And that brings us to phase 2, the universal operators.
The operators are the bridge.
Mm-hmm.
They're the bridge between that internal conceptual knowledge and real-world execution. Their function is translating understanding into action, into planning, sophisticated tool use, and continuous self-improvement.
So this is the difference between a system that can accurately write a 1,000-page novel about building a spaceship and a system that can actually manage the procurement, the engineering, and the manufacturing to build the spaceship.
That is the perfect distinction. And their approach to execution, it maintains that abstraction-first principle by starting with high-level planning.
It's not just brute forcing every possible action.
No, absolutely not. The system plans not by brute force, but by reasoning at a high level, breaking massive tasks into conceptual goals and sub-goals. Using the cooking example again, if the operator is tasked with making a complex French dish, it won't plan every individual hand movement down to the micron.
It's not thinking about motor neurons.
It's not. It reasons at the high level. Goal 1, prepare sauce. Sub-goal 1A, achieve emulsion. Only when it's absolutely necessary does it dive into that granular control, calculating the necessary torque on a robotic arm to whisk at a specific speed. This high-level conceptual planning is what makes it so incredibly efficient and adaptable to new tools and environments.
And this high-level capacity is also what unlocks the crucial self-improving aspect. The ability to not just use, but to create tools.
That is, you could say, the ultimate proof of general intelligence. These operators allow the AI not only to use existing tools APIs, database systems, robotic manipulators, but critically to design and build new ones when the existing means are insufficient for a novel task.
So if a carpenter needs a specialized saw that doesn't exist, a human can design and build one.
And Integral AI claims their system can do the same, computationally and physically.
The AI sets its own curriculum, essentially. And we saw a demonstration of this ability through what Integral AI calls active learning and experimentation.
That's the action loop in practice. The model proactively sets its own experiments to fill its knowledge gaps and to master new areas safely. And the demo they cite is just fascinating.
The drug discovery one?
Yes. The AI autonomously planned complex scientific experiments. And these weren't simple physics simulations. This was simulating drug discovery pipelines through robotic systems. And it generated novel, verifiable knowledge from the results.
So it's an intelligent agent proactively seeking out and creating new information rather than just waiting to be prompted or fed data.
It becomes a scientific partner.
Okay, so finally we need the infrastructure to support all this dynamic growth and continuous action. And that's phase 3, which is split into 2 parts, Genesis and Stream.
Right. Genesis is the foundational back-end platform.
Right.
You can think of this as the nervous system where all these AGI agents can plan, act, and learn simultaneously in both digital and physical environments. It's the secure, scalable, operational hub that allows the intelligence to be truly embodied and coordinating.
And Stream is the front end, the user interface.
It's the adaptive human interface. And the core concept here is that our interaction won't be through simple, isolated prompts, like talking to a search bar. It's designed for natural, ongoing collaboration with the user.
Like a conversation.
A dynamic conversational partnership with a system that is constantly learning, acting, and updating. It's a collaboration that mirrors the relationship between, say, a human architect and a highly competent chief engineer.
The technical blueprint is, I mean, it's astonishing, but what truly elevates Integral AI's claim, for me, is the profound philosophical cornerstone they've built the entire system upon.
Hmm.
Tarifai's vision isn't just about maximizing computational efficiency or corporate profit. It's explicitly moral and philosophical.
It's a necessary move, frankly, because if you are claiming to create a system that can self-improve and eventually manage massive operational tasks for society, you have to have an ethical foundation beyond simply don't be mean.
Right.
And they are grounding their entire mission in the concept of freedom.
But they define it in a very specific way.
A very specific way. It's defined not just as, independence, but as the ideal state of infinite agency and possibility for humanity.
Infinite agency, that's a huge claim. It suggests that the core aim of this AGI isn't to replace us or make decisions for us, but to exponentially empower us.
That is the explicit claim in their manifestos. The goal is not to replace humans or automate all decision-making. It's to expand our collective capacity to act, to create, to decide.
So the AGI's job is to give us better tools.
Better tools, more options, the capacity to tackle problems we couldn't even formulate before. Tarifai argues that if AGI achieves superintelligence, its sole focus must be on enabling greater human possibility, rather than just, delivering better quarterly results for a corporation.
And this is why the alignment framework they propose is so unique. They formalize this ethical mandate through something they call the alignment economy.
Yes, this is their proposed social and ethical system, where all actions, whether they're taken autonomously by the AI or guided by its output, are judged by a single metric.
And that metric is
how much they increase or decrease human freedom, defined as agency.
okay, so an action that successfully cleans up ocean pollution might increase freedom by removing a public health threat and opening up new possibilities.
Right.
But an action that secretly monitors a user's health data and manipulates their decisions would decrease it, even if the outcome was ostensibly positive, like better health.
Exactly. This framework treats alignment as agency itself. It's a profound shift because it separates the conversation from the current standard approaches used by their rivals, like OpenAI or DeepMind.
Right, because those systems historically rely on technical guardrails. Things like RLHF reinforcement, learning from human feedback, or just a complex pre-programmed safety filters.
Which means those systems are aligned by learning what humans don't want, the filters, or by being guided to obey human instructions.
They're about obedience and safety rules.
Right. They're about control. Integral AI is proposing a moral system grounded in actively expanding human agency. They argue that filters and rules are just insufficient for a true superintelligence, because a system smart enough to be AGI will eventually find ways around those filters.
Okay.
It's an arms race you can't win. They claim the only way to truly align it is to give it a fundamental moral directive, maximize the capability and possibility of its human partners.
A philosophical concept that scales with the intelligence. It becomes more robust the smarter the AI gets.
That's the idea. And this principle of expanding agency, it leads directly into Tarifai's vision of the future infrastructure. The supernet.
The supernet.
This is the realization of the alignment economy in the physical world. It's described as a vast, connected, coordinating ecosystem of embodied AGI agents.
So advanced, ubiquitous robots and autonomous systems.
Yes, coordinating everything from factories and infrastructure to complex scientific labs and even individual households.
So it's not just a digital network, it's the operational backbone of civilization itself.
It is the operational intelligence. Tarifai sees AGI not just as a powerful digital brain, but as a fully embodied intelligence that can shape the real world directly and fluidly, based on the abstract goals set by human partners.
And this brings it all back to his decision to set up in Japan.
It closes the loop. It underscores this vision. The AGI's ultimate purpose is to manipulate the physical world and expand human capability within it, using this supernet as its interconnected nervous system.
Okay, so whether skepticism or belief dominates the conversation around Integral AI's specific claims, the reaction from the broader world confirms that the discussion about AGI has shifted. It's gone from hypothetical to immediate policy concern. This Tokyo announcement hits a specific nerve because it aligns so closely with what the established tech titans are already acknowledging.
Oh, absolutely. Let's start with DeepMind. They are perhaps the greatest rival to Integral AI in terms of pure research pedigree.
And their co-founder, Dee Sasabis, has been unequivocal lately.
Unequivocal. He recently stated that AGI is on the horizon, calling it the most transformative moment in human history. And he's doubling down on a very near timeline.
He's saying 2030, possibly sooner.
Right. But the key convergence point here isn't just the timeline. It's the technical roadmap. Hassabis has specifically pointed to world models as the key developmental step required to get there.
Which is a clear echo of integral AI's universal simulators, right?
A direct overlap. World models, or WMPs, are systems that don't just process text or pixels. They actually build an internal model of how the physical world works. Causality, physics, relationships, context.
The blueprint.
The blueprint. And DeepMind's pivot to world models is hugely significant because it signals a conceptual surrender on the pure, unstructured reinforcement learning path that defined their early success with things like AlphaGo.
It's an admission that that path has a ceiling.
It is. It confirms that the established leaders believe the path to general intelligence requires structure and an internal representation of reality, exactly what integral AI claims to have engineered with abstraction-first learning.
So you have the establishment saying AGI is imminent and identifying the precise architectural component needed, the world model, while this company in Tokyo is claiming they already built and perfected that architecture.
It puts immediate, intense pressure on DeepMind and OpenAI to demonstrate their own world model capabilities publicly.
And that pressure is what transforms this from a technical rivalry into a geopolitical and ethical crisis waiting to happen.
Because if one lab really has achieved this milestone, the clock has run out for policy development.
Mm-hmm.
And this urgency is why the conversation has now pulled in perhaps the world's oldest and largest moral authority, the Vatican.
AGI is now an ethical and spiritual issue, not just a technical one. Tell us about this determined effort to bring this to the highest level of the church.
We're tracking the work of a researcher named John Clark Lavin and a group he refers to informally as the AI Avengers.
Okay.
Their goal is to convince the Pope, Leo XIV, to launch an official binding consultation on AGI before that danger window for policy development slams shut.
And their argument is that if we wait for independent scientific verification of these claims,
Which would take years.
right, the reality of AGI will already be baked into global infrastructure, and any policy will be too late. It'll just be reactive.
It's an interesting tactical approach, using the Vatican's moral authority as a proactive policy tool.
Yeah.
Lavin has been working quietly, holding seminars and briefings for scholars and priests in Rome, familiarizing them with the concept of general self-improving intelligence.
And Pope Leo XIV is, surprisingly, ready to listen.
Very ready, it seems. The source material notes he's quite tech-savvy. He even has a strong background in mathematics, which give him a better conceptual grasp of the computational science than you might expect.
And he's already made AI a defining issue of his papacy.
He has, speaking repeatedly about the risks it poses to human dignity, to labor, to justice. And he's preparing a full AI-focused encyclical.
For our listeners, an encyclical is not just a sermon. It's a major, binding, teaching document for the entire Catholic Church. The fact that the Pope is dedicating one to AI speaks volumes about the perceived gravity of this challenge.
Absolutely. So Levin's effort culminated in him delivering a personal letter to the Vatican, urging the Pope to launch a formal scientific consultation on AGI through the Pontifical Academy of Sciences. And this is the crucial policy mechanism.
That's the same rigorous process the Vatican used to develop its official position on climate change.
The very same. A process that involved years of expert testimony and interdisciplinary consensus building. So if the Vatican uses that mechanism for AGI, it signals they view it as an existential threat or opportunity on par with global warming.
It immediately moves the issue into the domain of serious global policy.
And the letter has been received. It reached one of his secretaries and is officially in circulation, which means the hierarchy hasn't dismissed AGI as science fiction. They're treating it as a genuine, imminent moral challenge.
And the Vatican's role here could be unique. They're not developing AGI themselves.
No.
But they wield this massive soft power, 1.4 billion Catholics globally, and diplomatic channels that reach everywhere.
And this positioning allows them to act as a truly neutral bridge between the East and West, specifically between the United States and China, where the majority of frontier AI labs are based.
A neutral moderator.
Exactly. The ethical deployment of AGI will require a global consensus that transcends geopolitical divides. The Vatican possesses a unique moral authority that can convene high-level dialogue in a way that no single nation-state or corporation can. Their entry into this conversation confirms that AGI is now spreading across the table, encompassing technical, political, ethical, and spiritual concerns all at once.
Okay, So this deep dive has shown us that the claims coming out of integral AI are both incredibly specific and audacious, and they are forcing the entire AI conversation to accelerate.
Hmm.
We've analyzed their three measurable criteria for AGI achievement, autonomous learning, reliable mastery, and that profoundly groundbreaking biological energy efficiency.
We've explored the abstraction-first architecture, built on the neocortex analogy, which aims to solve those crippling problems of pattern matching and catastrophic forgetting.
And we detailed their expansive vision of superintelligence moving through universal simulators, the conceptual model, and universal operators, the action planner. All of it grounded in a philosophical mandate they call freedom.
A mandate designed to maximize human agency. The key takeaway here is that the conversation about AGI has irreversibly shifted. It's moved from purely hypothetical to dealing with prototypes and policy responses.
The industry leaders like DeepMind are echoing the need for world models, the very architecture integral AI claims to have built. And the moral authorities like the Vatican are scrambling to develop policy and ethical frameworks for systems that are increasingly appearing to be prototypes, not distant dreams.
So what does this all mean for us, for you, the listener? It means the time for casual observation of AI progress is, well, it's fundamentally over. We have reached a point where systems designed to act as the operational backbone of civilization are being actively built and tested.
And under an ethical framework designed to expand human freedom. But this expansion of agency is reliant upon that vast, fully connected, coordinating intelligence ecosystem we discussed, the supernet. A network of embodied AGI agents managing everything from logistics to scientific discovery.
And that raises our final provocative thought for you to mull over. If AGI is explicitly designed to expand human freedom, our infinite agency and possibility, but relies on this vast, interconnected supernet of embodied superintelligence to operate and manage the physical world on our behalf, who actually holds the agency?
Where does genuine human control truly begin and end in a world where the operational layer is managed by an intelligence designed to be better than us at almost everything?
That's the question we must answer quickly. Something to think about until our next deep dive.